or taken a test. Discrete means I could have fractions. I could have decimals. I could drink, in John's water bottle, it could be 7.2 ounces of water. It doesn't have to be exactly 7. If I'm counting the number of books on Riley's desk, she only has 2 books on her desk. She can't have 2.5. That's discrete. If they're countable whole numbers, discrete. And continuous kind of says the thing. It continues all the way through the number line. You take every single number on your number line. Think of it that way. Decimals and fractions. The amount of time it takes to get to work, it could take me 3.5 hours. It could take me 2.2 minutes. Okay, so if it's continuous, if I can make a decimal, I'm continuous. The number of books in a university library, I think I missed that, sorry. Discrete, they're countable. Can't have a half a book. The number of volume of blood drawn in a blood test, continuous. If I can say I can have a half, it's continuous. The number of tornadoes, it's either a tornado or it's not. It's discrete, countable. The number of messages posted each month, discrete. Now, the difference between the number posted and the average number of text messages is different. The average could have decimals in it. We learned that, right? Because doesn't the mean have 1 decimal place more than the x values? So we know that averages, when they say the average family has 2.3 children, do they say that this is a 0.3 child? No, they take an average. An average, the mean, is 1 decimal place more than the decimals. So if it's a discrete value and it has no decimals, your mean will have a decimal. The amount of snow in inches, could I have exactly 3 inches? Could I have 3.5 inches? Yeah, if it's continuous, if you can have a half, you're continuous. So this is what we did on Friday. We looked at continuous versus discrete. We did most of that. We started our table and we found that probability is, again, part over whole. Our probability looks a lot like our relative frequency from our frequency histogram. So we can make a table out of all the things that happen, and we can make a graph out of it as well. It's our relative frequency graph with one difference. Your y-axis says P of x instead of relative frequency. Okay, so let's continue with this. If this is a little on the dry side, I'm sorry. There's no way else to teach this. Statistics in itself is exciting when you're looking at different statistics and you're analyzing them. But some of the things we have to do to get there is not always that exciting. Just like with anything else that you do. And if you decide to be a statistician, you will be crunching a lot of numbers along your way. Where I give you only like 20 things to put in the table, you will get like 20,000 things to put in the table. Of course, you'll use software to do that, but you'll still have to do it. Okay, and the boring part of this chapter, I'm going to be able to like skip over a little bit. Thank you. Give me that lesson or I was sorry. One. Yes, the problem is I don't have any more for some odd reason, so I'm going to have to make more copies. I think what might have happened when I brought it downstairs for copying, I might have had the wrong amount of copies on it. Okay, so we left off, I wrote myself a note at example 3. So why don't we start with putting this in our, well, you don't have to put this in your book, because we're just going to take a look at, is this a probability distribution? So we had 2 characteristics that we discussed. 2 characteristics to tell if it was a probability distribution. If this is on your note page, so make sure you highlight this. One of them says each probability has to be between 0 and 1. Has to be between 0 and 1. which fraction, decimal, even percentages, that's fine. The second one says the sum of all probabilities for that particular thing has to equal 1. You'll see this. Summation equals 1. Do we have a negative probability? No. No negative probabilities. So the minute you see a negative number, not a probability distribution. So we look at this guy. Number of days it's going to rain. Remember, sometimes we said you'll have a 0. Sometimes you won't have a 0. These are all valid. They're between 0 and 1. Next thing we have to do is check, does this add up to 1? So add it up for me and see if it adds up to 1. We can eyeball the first part, looking at the probabilities, but the summations, you got to see if they add up to 1. Those two things have to happen for this to be a probability distribution. And doesn't that make sense? It makes absolute sense. We've been doing that with probabilities. All the parts add up to 1. Probability of the head is 1/2. Probability of the tail is 1/2. They add up to 1. So they do. So we say, good. This is a probability distribution. All we have to say. Try it too. If we constructed it, we know it's a probability, so we don't have to do that. Okay. This guy, number 1 in example 4. Does it meet the first condition? Do all the probabilities go between 0 and 1? Yeah? So the first condition it meets. Does it meet the second condition? Do they add up to 1? You can have fractions and decimals mixed. That's okay. It does not add up to 1? More than 1. So this is not a probability distribution.
That's not either.
Ah! Good. This is negative. And what else is off? 5/4. What about 5/4? It's greater than 1. Greater than 1. But if I add them all together, do they add up to 1? Maybe. So is it good if they add up to 1? Nope, they have to meet both conditions. They have to meet both conditions, and this one fails the first condition. So this is not a probability distribution either. Okay? Okay, decide whether these are. Do the probabilities fall between 0 and 1? Yes? Now we have to see, do they add up to 1? We can have different fractions, we can have decimals, we can have them mixed together. Because it passed the first part. It falls between 0 and 1. The first one adds up to 1? The second one meets all the criteria, but it doesn't add up to 1. Sum is not 1. So we go with this. Very, very two basic principles. The probabilities have to be between 0 and 1, and they have to add up to 1. Very, very basic. Okay. So before we hit this, I'm trying something different this time. I want to have you go to the homework page, and let's have you test these guys. Let's see what's up here. Let's have you do a little piece at a time, maybe. Maybe this will help. Let's see if they have that. Look at number 25 on page 198. Page 198. Test. Number 20. Everybody put this in your notebook so you're able to do this. I'm just going to run mine down this way, and this is fine. This is your x, this is your frequency, and we're going to create a column P of x. Actually, you're going to create a column. Okay. How do I create that column P of x? Good. You have to first take a total of your frequency. How can I do part over whole without knowing what the whole is? Probability is just part over whole. So add them up. See what you come up with. What you get, John? I got a 192. Anybody else get a 192? So how do I find the probability now? Angelise, how do I find the probabilities? What did I just say 2 minutes ago? How do we find probability? Part over whole. So we know the whole part, we know the total. So this is 6 over 192. How many decimals do you give me? 3. So everybody fill this in. I want 3 decimals. And doesn't this look like your relative frequency when we did relative frequency, part over whole? Somebody did the tally for us already. We didn't have to tally. And we don't have classes. That's the only difference between this and relative frequency. Once you get them, add them all up and see if they add up to 1. Why might they not add up to 1? What if we round it? What should we do if they don't add up to 1? Well, we could go to the decimal place, or we could look at one that was very, very close and just change it a little bit to make it add up to 1. Something looks like your circle graph. You know when you do your circle graph and you find your percentages? Sometimes if you find that there's too many that you're rounding up on, your 1 is not going to make it. But most of the time they will work. So now I want to make a graph. I want to make a graph of this thing. And this is the number of overtime hours worked in 1 week. Worked in 1 week. So it's only going to be in my first quadrant. What's going to go on my x-axis? What does that x represent? Overtime hours. Good. So this is a good label. How am I going to label my y-axis? I want to make a probability graph. So what am I going to use? My P of x. This is my probability distribution. I want to make a probability graph. This used to be like my relative frequency. Part over whole. Now the bottom, remember, They're discrete values, so we're just putting them in like this. If you want to put this here because we didn't start it at 0 there, that's fine, but it's okay if you don't. Again, your bars are going to look like our bar graph, our frequency bar graph. They're going to touch. This guy has to go from 0 to what's the highest it has to go to? Think money. What's the highest amount that I have on this? Put 297, so like 30 cents, right? So if I go by 0.05, a nickel, a dime, a 15 cents, 20 cents, 25 cents, 30 cents. Just think money. It helps get the decimals in. Remember, 0.05 is not the same as 0.5. And then we put our bars. Just like your relative frequency. We don't have any classes, we have discrete x values. These are discrete numbers. So for 0, and we have a 0, it could have could you work no overtime hours? Yeah, we could work no overtime hours, just our work straight 40 hours. 0 is 0.031. So if I look at 0.031, would it be up here or would it be all the way up here? Would it be down here or all the way up here? Down here. It's like 3 cents. Think of money. It's like 3 cents. Make that with your little bar in the middle there. The next one says 0.063. Started there. It's a little bit more than like 6 cents. The next one is a little over 15 cents. Just think money. Then close to 30 cents. Then 21 cents. 22 cents. Then a little over the 15 again. A little bit higher than what I was before. And 0.083. Where am I going to find 0.083? Between what two values? Good. 0.05 and 0.10. It's 8 cents. So somewhere over here. There's your probability distribution graph. It looks just like your relative frequency graph, but we call it a probability distribution. We found our probabilities the same way you find your relative frequency, part over whole. So we added up the frequency. We didn't have to tally anything. It was given to us. So we added it up. I don't want to see the frequency on here. I want the probabilities on here. It's for probabilities only. Yes? Question? Can everybody do this? All right. Now, we're kind of going to play this other part a little bit differently. They go into, and I was going to go into it, but I decided against it. So you guys got lucky. Standard deviations. Excuse me. Thank you. Okay, I'm going to not move this because I'm going to do it on this. But if you take a look at page 194, they do theirs a little bit differently. Sorry. Thank you. They do this. They make another column. They do x times p of x. And what this does is this. It takes this column times this column and it puts it here. So for now, we're going to do that part. So on this graph, let's make one little more column and add this down. I'm just going to show you how they get the mean and then how we're going to do the mean. Because we don't need to go through all their problems. So anything times 0 is 0. Anything times 1 is itself. Just go 2 times 1.5. 1. Just make me a graph down here. I know I wrote on it, so the best you can do it. Everybody see where I'm getting these from? I'm just multiplying my first column and my third column. I want to show you where they get this from, but we're not going to do it there from then on. But what happens is you have calculators. And if you work on this in college or in the business world, you'll have a program that does this. You'll never do this by yourself. If I add all this up, it's actually going to equal my mean. So they like to do this third column, fourth column actually, and they like to add all those up and come out with your mean. So if we add all these pieces together, so after you do that, kindly add them up. We'll make sure we come out with the same thing. Tell me what you get for the mean. Just add them all down. All the ones in green. The x times the p of x. We're doing with the table that we just made, so this way it makes sense for you. Anybody thought the total? I just want to make sure mine's right. 3.1, 3.417. Very good. What does that represent? How do I interpret this in words? In terms of this scenario, this is overtime hours. What does that mean? Got it? Okay. That's great. You're welcome. What does this mean to me? Okay, the average amount of hours that they worked overtime, a lot of people did, the average amount of hours worked overtime is 3.147. Does that make sense according to my chart? Does this pretty much almost look like a normal curve? Doesn't this look where like my mean would almost be at the top of that curve? Shouldn't my mean be close to that? I got a little bit of a tail going on, so maybe my median and my standard deviation might be real close to that too, right? Because it almost looks like a normal curve to me. A little bit of a tail dragging over here. A little bit of a skew to the left, if you will. Okay? So maybe my standard deviation and my mean is pulled a little bit differently. Now, we also learned how to do mean in your calculator. How did we take a frequency table and find the mean? Using your calculator. How did we find the mean of a frequency table? Of a frequency distribution table? In the statistics area, in the L1, L2, right? Okay, so this is what I want you guys to do. Listen carefully. For this, from these three rows, I want you to do L1, L2. And the ones that are stat, find me the mean and the standard deviation and the median. These two rows, I want you to do this. I want you to do L1, L2. This guy. I want yours in red. And I want everybody to find me the mean. Let's do the population standard deviation and the median. My board is really long. Find me the mean. But I got two different groups doing two different things here, right? You guys are doing L1, L2 like we always did with the frequency, because that's how we do these things. These guys are doing the L1 as the x, the L2 as the probability. Still missing my calculator, guys. Nobody had my calculator. Still missing my calculator. So the green, let me put the mean and the standard deviation. And find me the sample standard deviation too, if you will. Anybody from the first two columns done? Mean? Chris, what do you got?
2.
2?
Oh yeah, it's just 3. I thought you were talking about the next one.
The mean is just 3?
Yeah.
Really?
Yeah.
It can't be. Okay, what's your standard deviation?
2.
Just 2?
3. It's 2.16.
You all got that? Okay. In the red zone, what's the mean? 3. The standard deviation? Two. Probably the way it rounded, right?
Yeah. Well, standard deviation, I'm confused. Population is
Population, the OX
Yeah.
is the population.
Oh,
But your SX is what?
that was 2.16.
Oh, I guess I just read it wrong.
Wait, you have an SX?
Yeah.
Ah. Did you do this one and this one?
Yeah, I did the X.
You did this one.
No, I did not.
If you did this one, you can't have an SX. So no one had an SX here, right? What was your median? 3? For some odd reason, that mean should have come out the same as this mean. I'll have to take a look at that.
Yeah, I got 3.41.
3.41, right? Okay, something's off on this. Maybe I copied the wrong number down. I don't know. I'll have to take a look at that. The OX 1.45? Really? These guys got 2 and you got 1.45? Did you guys get OX 1.45? 1.45? I'll have to take a look at that. Okay, so the median 3, did we agree on the median? And the median is close to the mean, isn't it? Look where your standard deviation is. Isn't it skewed this way? The standard deviation is a little bit skewed. Well, I can't really tell on my standard deviation. I didn't do my mode either. What's the mode? What's the mode right here? What's the mode? Well, the highest number is 57, right? So this is also the highest. It's close to 3. So don't your mean, your median, and your mode almost fall together here? But it's a little bit skewed this way because your standard deviation is a little bit, well, I can't figure out which one it is yet, but it's somewhere along in here somewhere. So it's skewing this a little bit because of this tail. Your mean is to the right, I don't know. So we're a little bit off on both of yours. I have to figure out why. But what this does is, this calculates your standard deviation. This is the part that I want you to see right here. The reason we don't get a sample standard deviation, and I'm going to avoid going through the whole standard deviation table this way, is because when you did standard deviation, you took the total of that thing, and then you took the square root of it. And it was the difference of the squares divided by n. Okay, when you did the sample, it was the sum of the squares. This doesn't matter. Divided by n minus 1. N minus 1 to give me that. This is what happens. If you do the frequency like we did in the past, I'm able to take the frequency and subtract 1 from it, aren't I? If you do this piece right here, this piece in here, what happens is, what do they all add up to? If I did that as a frequency, L1, L2, and I put this in my frequency column, what's the sum of this column? 1. So if I do 1 minus 1, am I allowed to divide by 0? So if you use this as your L1, this as your L2, you just don't get a sample standard deviation. Everything else should have been the same, and I don't know why it wasn't. So I'm going to do this again later, because I just winged this because I decided to show it to you all on this one. But they should be exactly the same. The only thing you're not going to get is a sample standard deviation. Riley, did you figure out what was wrong?
For the frequency list, I put an L2, so I thought it was the list was
Uh-huh.
So I think if you were getting 3 and 2 and 3, you were not putting in L2.
You didn't put in the L2. So you got 3.415, 3.41?
Yeah.
Because we should have, because that's what we found right here. That has to match that. And this would be 1.45. Good. Yeah, thank you. That's probably what happened over here. All right, so these should be the same. My point in showing you all this is, do we have to do that big standard deviation table out? No. We can still find our mean using our L1 and using our probability as our L2. We can still find our mean. We can still find our standard deviation. We can still find our median. The only thing we can't find is a sample standard deviation. So when your sample standard deviation is blank, everybody kind of over it. So tomorrow we'll do a little bit more with this. We'll do another one. This one from the book.
Show me what I was talking about.
Yeah.
I'll start to end.
Show me how you do it. Exactly. Okay. This is good. Now show me how you find your thing.
Now this time I didn't do it on the
Yeah?
That's the one I'm working on.
Yeah, that's fine.
That L2 is
That's what happened. See, that's great. Because the middle number there, if you add them up together, is 3, right? That's what I think was happening to you guys over here when you gave me 3. Nobody put in their L2. And Riley caught it.